Hello and welcome to another Thinking Particles 7.1 tutorial video. In this video we will discuss how to create a cutting effect with material point method and continuum mechanics. In this video we will see how we can adjust and control the Mpm material properties on a procedural way. Before we do so, let's have a look at the scene. The scene is made out of very simple objects. We have a floor, cutting board, we have the butter stick and a cutting knife and lights as well. So pretty simple, straightforward setup in 3D Studio Max. Let me now select Thinking Particles and let's bring up the properties of Thinking Particles, our interface. And our interface allows us to control where and how we create particles. So the most important step, or step one, is creating particle groups so that we know what we're doing and where we store stuff. So we will have the butter gravity and Mpm particle groups. Inside of the Mpm particle group we also have subgroups. In the butter group, we will put in our butter stick, our mesh object, which is a simple box. Then we have a gravity group. Underneath the gravity group, we have our Mpm particles. And inside of the Mpm, we have the inside and outside particles. The Mpm particle group also has data channels, which is very important. We have a data channel for UV coordinates that we will use. And we have a stress out and stress in. And we also have a 3D coordinate channel as well. On the dynamic set side, it's all straightforward. We have a coordinate dynamic set, we have a gravity dynamic set, we have a simulation dynamic set, cut simulation dynamic set that I will talk about why we use that and what we are doing with this cut simulation dynamic set. Mainly it's meant to clean up and create straight cuts through continuum mechanics particle systems. And then we have our surfacer, where we use an OpenVDB shape for both the outside and inside of our butter model. Let's start with the create group and explore how we did the scene. So first we need to get objects into Thinking Particles, and we use that with an object to particle. And there we pick our butter stick object, which is a simple box. And we store this object in the butter particle group, and we also make sure we check instance shape. This will give us the geometry and all related data, including UV coordinates and everything. So we get the mesh into Thinking Particles, and now we can work with the mesh in Thinking Particles. Let me show how we get the materials into Thinking Particles. So the materials are just applied to the standard 3D Studio Max object. So it's a standard 3D Studio Max object. It has UV coordinates applied, and it also has a material applied, a standard material. So that's all we need to do, is have a standard 3D Studio Max object with proper materials on it, proper material IDs and everything. So this is how we get the material and the object and the shape into Thinking Particles, by checking the instance shape option. The next group we have here is responsible for creating the actual Mpm Simulation Particles. So the material point method particles, or the continuum mechanics particles, need to be created based on our shape of the object. So what we do is we create an outer hull, so to say, that is our aluminum foil, and an inside, which is the butter. We do that with the simple deform, and the simple deform is just selecting our butter particle. Remember, it includes the geometry and full information from 3D Studio Max. However, we don't want it to deform, so simple deform is not deforming this object, so we uncheck the particle choice, the vertex particle choice. Simple deform is just used here, or abused, to create particles. So what we do is we create the outside particles. That's our foil, aluminum foil, the wrapper, and we set a raster and create the particles on the surface of this box. The inside particles, which is our actual butter, the inside particles are created in a similar way, but as a volumetric effect. So we have a raster in 3D space, and we want to make sure we have a little margin from the surface. So we stop right before the surface, so that we actually get two objects and not one object that's melting together. So we actually have the wrapper foil and the butter inside. And then we have our particle data, and it's set to the Mpm particle group, and we do that so that we can access important data channels. So we want to access the stress in data channel to give it an initial value of 1, which is a multiplier. 1.0 means it takes whatever stress value our Mpm solver is calculating at the start of the simulation. And we do the same for our volume particles. So the first particle data is the surface particles, the second is our volume particles. So now we have assigned an initial stress value or multiplier for all the particles we create from the outside and inside particles. The Mpm is keeping all the information, our main group, so all subgroups will get these data channels as well, the stress out, stress in values. And the numbering is important as well. We will come back to this later. So then we have our gravity, as already mentioned, which applies a gravity to the gravity group, particle group, and everything underneath will also receive the gravity. Now to our simulation dynamic set. In the simulation dynamic set, we have the flow Mpm, we have the flow boundary, and the flow solver. So that's the basic setup we have, and in the flow Mpm setup, we choose our material property or the material type we want to simulate. Right now it's a von Mises material type, and this is chosen because we have the yield value, which gives us a cutoff threshold where the material gives or breaks. So this is why I chose the von Mises material property. This allows me to cut the material. Other material types, for example jelly or any other material, is not meant to get cut or break. It will stretch or get soft for a long time. The next thing is our flow boundary. We have the cutting board and we have the knife in there. We want to have collisions with both. So our butter should lay flat on the cutting board, and the knife should be able to create a collision as well, so that we can actually cut our Mpm particles. An important part is the data channels. So we have an input data channel 3 for the stress factor, and we have an output data channel 2 for our stress output. And these data channels have been defined in our Mpm particle group. We have stress out and stress in. So this allows us to externally feed in stress values or to read the stress values that are calculated by the Mpm solver. The output is a calculated stress from our simulation. The input is what we feed from the outside into our system. Now let's have a short look at the cut simulation dynamic set. This dynamic set is a very interesting one. We grab all the Mpm particles, including inside and outside. So we treat that as one continuum mechanics construct. So all particles are in the same Mpm solver. So we grab inside and outside, and based on a threshold, we decide if we want to do something. So everything that falls outside of our normal pressure values we can expect in a normal behavior, when it's not under stress, our material will behave normally. And if it falls outside, we start with the flow data. So we grab the collision. So we check, is there a collision happening when it falls outside of this threshold? If there was a collision, we kill the particle within one frame, so the particle lives for one frame only. And then, if that threshold is triggered, we kill the particle. And then the other setup is, what we have here, is the particle data. The other particle data is meant for stress in, where we remove the stress of the particle that is under collision, which means it's in the knife because it falls out of our threshold, and we set it to 0. That means this particle is removed from the Mpm simulation in one direction, but all the other particles are still influenced or are able to still influence this particle. And that will give us the clean cut, and I will show you what I mean with that, because we could have done it with a pure Mpm simulation as well. But for the last dynamic set, just to mention it, we have a surface for the inside with the butter material, and we have a surface for the outside with our wrapper foil. So we just apply the material and create the open VDB shape around the particles. And we grab the UV coordinates from our original object and transfer them to our particles so that we get the same mapping on our particles. So wherever the particles are placed, we get the proper mapping. And we stored the UV mapping in the beginning in our data channel. So this is how we transfer the UV mapping between our mesh object, the butter stick, and the particles. So the open VDB shape transfers our UV coordinates, the actual UV coordinates or 3D coordinates. It's for both material types is possible. So that's the magic trick, so to say, to transfer the UV coordinates to our particles or surface of created out of our particles. So let's have first try and have a look if this dynamic set actually means something for our simulation. Let me first turn it off. I'll right click on that. So now the whole dynamic set is off. So we are doing pure material point method simulations here when we do the cut. So let's have a look how our cut looks like. And you will notice that we are dragging our right side along with us. And I already can see in the viewport there's something strange going on without activating our dynamic set here that creates a clear cut. Let's have a rendering just to make sure that we can see the differences. So while we render here, we will do 2 renderings and then switch back and forth between the 2 renderings. But you can already see in this rendering, we have this non-clear cut. These dragging particles are still influencing each other because this is a continuum mechanics solver. So that means particles can influence each other over a distance. This is how continuum mechanics works. So I'll activate this cut sim dynamic set, and now based on the threshold we decide when we want to kick in. So everything that's under high stress or compression will trigger a flow data, and then we will check, is it colliding with something? Then because it has a high pressure, we assume it's colliding with the knife. Then we will make a particle die within 1 frame. And in addition to that, we instantly remove the particle from the stress calculation by setting it to a low 0 stress. So this is now our cut with the dynamic set. And you can see right away, no influence anymore, no dragging along, clean cut, smooth, clean cut. Keep in mind, this is a tutorial video, so the resolution, you can up the resolution so that it gets crisp and nice and fine. But for the sake of the tutorial, we have this lower resolution, but you can clearly see the dynamic set that cleans up our continuum mechanics effect is working. So we have full procedural control over our continuum mechanics solver. And that's really a powerful feature that you won't find in any other product right now on 3D Studio Max. So we can control our material point method in detail in a procedural way. And what we did here is, just let me recap, we kill the particles under high stress and compression, and we also remove those particles by setting the stress value to 0, artificially setting it from outside to 0. So this is actually the whole magic we have here in cutting butter or fish or whatever you want to cut with our new material properties and material solver. So how do I get the thresholds? How do I know which is normal pressure, which is high pressure, and where the pressure is? So for that we use a standard thinking particles show info tooltip function that will give us per particle information. So I'll turn on show info tooltip and just hover above particles. Let me turn on the data channel, and now I'm hovering across the particles and I can see stress out is 0 right now, stress in is 1 right now. So right now we are have not started the simulation. Let's start the simulation a little bit, and we will then see in real time we are doing a stress visualization. Now we can find out what is the stress value, and right now it's minus 0.07, sorry, and there we can go over these red and blue particles and find out high stress, or what we deem high stress due to the knife putting pressure on it, and that's how we set the threshold. So that's the whole trick about getting the threshold where we know it's normal and not under pressure. And everything that falls outside of this, we assume it's under pressure, and then we do our little particle die and low stress trick we have here. So this wraps the tutorial up, and I hope you enjoyed this one, and check out our other tutorials as well, and thank you for watching this tutorial.